In this video, we're going to look at how we can evaluate logarithmic functions. And to do that, we're going to look at using the idea how we can rewrite our logarithmic function into an exponential function. So remember, if we have y equals log base a of x, then we know that we can rewrite this as a to the y equals x. Log base a, so a is your base, so that is a here. And then remember, when you take the log, you're finding the exponent, so that's a to the y equals x. So to evaluate this logarithm, we want to rewrite this in exponential form. So the base here of log base 2 of 8 equals y. The base is 2, so that's 2 to the exponent y equals 8. So now we probably can look at this and determine the value of y, but we need to rewrite the 8 so that it has a base of 2. So we know that we can certainly write a with a base of 2 as 2 to the third power. And once again, because the bases here are the same, then the exponents must be equal. So therefore, y has to be equal to 3. All right, the next example, log base 3 of 81 equals y. Once again, our base is 3. The exponent then would be y, and that has to be equal to 81. So how can we write 81 so that it has a base of 3? Well, 3 times 3 is 9, times 3 is 27, times another 3 is 81, so that would be 3 to the 4th. So therefore, y equals 4. And then we have log base 2 of 0.25. Now for this one, it may be to your advantage to rewrite this instead of as a decimal. We know that 0.25 is the same thing as 1/4. And now we could think of this as 2 to the y equals 1/4. Okay, and we can write 4 as 1 over 2 squared, so we're getting close to the base of 2. And then we could think of this as 2 to the y equals 1/2, or I'm sorry, not 1/2. We want to move the 2 squared to the top, so we want to take this and move it up here. And remember, if we do that, we have to change the exponent. Well, the exponent is positive, so that's going to make it 2 to the negative 2. So therefore, we now have the same base, and that tells us that y must be equal to a negative 2. All right, now we're going to look at some examples of log 100 equals y. Now remember, there's no base here, so we know this is understood to have a base of 10. So if we rewrite this, then we're going to have base 10 to the exponent y equals 100. And if we match up the bases, we know that we can write 100 as 10 squared. So therefore, y has to be equal to 2. Now, what do you think we're going to do with log of 1 over 100 equals y? Well, once again, we still have a base of 10, so that means we have 10 to the exponent y equals 1 over 100. And we could think of 100 as, just like we did before, as 10 squared, but this is 1 over 10 squared. So just like before, we could simply move this to the top. And if we move this piece to the top, we have to change the exponent to a negative, so that becomes 10 to the negative 2. And then our y value, the exponent, would certainly be equal to a negative 2. All right, what about this last example? Log 3 equals y. Well, once again, the base is 10, so we would have 10 to the y equals 3. Now, this is a little bit of a trick question. We do not have any way that we can rewrite 3 so that we have a base of 10. So this one's actually going to require us to use our calculator. So this is not going to work to rewrite this example, okay? So we're going to use the calculator. And if you notice here, we have next to your number 7 key, we have a log button. Now, keep in mind, when I hit this log key, this is understood to be base 10. So this log button only works for logarithms of base 10. So we were looking at trying to find the log of 3. So here we would just type log 3, close the parentheses, and then we just hit enter, and we get 0.477. So therefore, this is equal to 0.477. And what that means is we have to take our base 10 raised to this power, and that's going to give us 3. So for example, if I was to take 10 raised to the power of this 0.477, now I don't want to round this number, so there's a way we can bring this answer down. We can hit second function and entry down here, the enter key on the bottom. Whoops, wrong one. Let's see, we would go 10 exponent, not entry, one answer, I'm sorry. Second function, the negative key, that brings down the last answer here of 0.477. So 10 to this exponent here, what do you think that's going to equal? And it equals 3, because what we're saying is 10 raised to what power gives us this 3? In this case, the 0.477. All right, so then we have log 1/5 equals y. And once again here, if we try to rewrite this, we would have 10 to the y equals 1/5. And there's really not an easy way to rewrite 1/5 so that it has a base of 10. So once again here, we're going to use the calculator. So we would just go to the calculator, and we could simply just type in log of 1 divided by 5. And we get a negative 0.699, a negative 0.699. Okay, so if you're not able to rewrite this as a base of 10, the calculator does work with this log button, but keep in mind this log key only works if you have a base of 10. All right, now we're going to look at evaluating some natural log functions. So we have ln of e squared equals y. So once again, we could write this. Now keep in mind, ln here basically means this is the same thing as if I was to write log base e of e squared equals y. So if we rewrite this in exponential form, we're going to take our base e, that's our base, and our exponent then is y. So e to the y equals the e squared. And now it's clear that we have the same base as e, so therefore the exponent y has to be equal to 2. And then over here, the next example, ln of e to the negative 3. Once again here, the base is e. And let me actually rewrite this again. This really means log base e of e to the negative 3 equals y. So again, we're taking this base raised to the exponent y equals e to the negative 3. The bases are the same, so we get y equals negative 3. And then again, for this last example, notice if I was to rewrite this, again, this really means log base e of 2.5 equals y. So that means we would have our base e raised to the exponent y equals 2.5. Well, there's no way that we can rewrite 2.5. So here, we can't write 2.5 with a base of e. So once again here, we're in luck. We're going to be able to use the calculator. And we want the natural log of 2.5. So if we go to the calculator, if you notice next to the number 4 key here, you have the ln button. So there's your natural log. And we want to take the natural log of 2.5. So we're just going to type in 2.5, close the parentheses, hit enter, and we get 0.916. So 0.916 is our answer. And once again, what that means is if we were to take a second function in this e to the x, so e to the power, if I hit second answer, that's going to bring down this decimal of 0.916290739 without rounding it. So when I hit enter, we should end up with 2.5. So keep in mind here, if it's possible to rewrite your base to match up your bases, then you can certainly easily calculate the logarithm. If not, if it's a natural log or if you have a log base 10, we can use the calculator. Okay, and soon we'll look at some other properties in the next video, how we can continue to calculate some of these logarithmic functions.